our substitution property of equality says this, that if A equals B, then you can substitute A for then you can substitute A for B anywhere you see it. Similarly, the transitive property of equality is very similar to, very close to, we can think of this as our syllogism. It's the same darn idea. It says that if A equals B and B equals C, then this implies, or then, and here's the symbol for implies. It's like supposed to be a big arrow. It looks like an equal sign, the greater than. We're going to take those ideas and combine them with some of the properties and things that we looked at last week. In particular, those properties that I said that we had on the algebra properties that were in like 105 or 106 that I made a note to on the previous note sheet. You're going to use those. We're going to use the substitution transitive. We're going to be not stumbling, but we're going to be creating and proving some what are called theorems that are coming up tomorrow in particular. We're going to start creating and proving our own theorems that are statements that we can get from all these other things that we know are true. And we can explain why they're true. We can prove them. And once we have them, then we don't need to start from scratch every time. We can actually, if we have the situation, we can explain. Okay. If you don't recall everything that we've done so far, a really good note-taking strategy and a study strategy in particular would be to go back through and maybe start making yourself a list of the properties and theorems and postulates and definitions and all those fun stuff. Start making yourself a list of those useful piece of information, like on a separate, like someplace separate in your notes. Just so, not as like a memorization technique, but as to just make sure you're familiar with all the ideas that we're hitting, because you're going to be using those ideas a lot as we go through as referencing them to be able to explain why some of these things are true. Let's take a look at our first idea here. Let's start with something relatively not so complex. So I'm going to give you this drawing. Here's a drawing. And I'm going to tell you that measure of angle 1 is equal to the measure of angle 3. From this drawing and knowing that, I'd like you to prove or explain to me why EBA is the same as angle DBC. Explain to me why those are true. That's what we're going to do in this proof. Okay. So before we write anything down formally, before we start giving like statements and reasons and all that fun stuff, I like to do a sketch or just a brainstorm. We'll brainstorm here first and think about, before we write anything down formally, why. Try to explain to yourself ahead of time. Why do you think this is true? Is it true in the first place by looking at that diagram? Should it be true? I think so. Yeah. I think so too. Well, now let's think of some reasons why. What are some things we could do to explain why it's true?
Well, it's kind of like angle 1 plus angle 2, and then like the other one is kind of angle 2 plus angle 3, and if angle 1 and angle 3 are the same thing, angle 2 is the same thing.
Yeah. So we know we can create some like equations here. We know we could create an expression for one of the angles, one of our bigger angles, by saying 1 plus 2 is like, say, DBC. You could create an expression for like angle EBA by saying that should be angle 2 plus angle 3. Knowing that 1 and 3 are the same, that should then we could do what's something you could do to show that these two expressions have to be equal to each other then. If they're the same. You could do what was this one under?
Substitution.
You could substitute like one of these two angles for the other in expression, and you end up with equal expressions. Would be kind of our plan of attack here. So we'll substitute. We'll do a substitution, and we'll show that they both should be the same. Kind of our general, just sketch plan of attack. Well, now we got to actually write this stuff down in a logical argument, in a formal statement. And we'll want to walk through how to do that together. Let's start with this one as a 2-column proof. So if you recall, then our 2-column format will look something like this. We'll have 2 columns. One will list the statements or all the things we're going to claim, and then we'll explain why we can claim them. We'll give the reasons or why we should say they're true. First, what's the first thing we should probably want to lay out in our proofs? What's true, the given statement. So we said that what? Measure angle 1 equals measure angle 3. And that was because I told it to you. That's because I told you it's true. It was given. Okay. So maybe our next thing would be to write down these relationships that we sketched out. So we'll say like angle DBC is equal to angle 1 plus angle 2, and what angle EBA is equal to angle 3 plus angle 2. What allows you to say that? What is that?
From the diagram.
From the diagram? What about the diagram though? So the angle addition postulate allows you to claim that allows you to create these two equations. Okay. Well, now what? And once you have these, what did the next thing in our sketch in our brainstorm session say we want to do? Once we knew that these, what do we want to use? What do we want to create? What do we want to do?
Substitute.
Okay, so we're going to substitute. What are you going to substitute, and what new equation is going to come about? You have some choices here. This is all totally up to you. You can go one way, you can go the other. It's totally your choice. What is one thing you could do?
Substitute angle 3 for angle 1 and angle 1 for angle 3.
You could do both of those, but I would recommend only doing one. So which way do you want to go?
Substitute 3 for 1.
3 for 1 into which equation? Well, the one that has the angle 1 in it?
Yeah.
Okay. So we'll substitute. We'll put 3 in for angle 1 into, say, this first equation here. So that gives us a new equation that says what? DBC is equal to, instead of 1 plus 2, we can say that's equal to angle 3 plus angle 2. And the reason we can do that is because you can substitute. That's just a substitution. Well, now look what you have. Now you have EBA is equal to angle 3 plus angle 2. DBC is equal to angle 3 plus angle 2. So now what can you claim? Now what should follow?
Angle EBA equals angle DBC.
Angle EBA equals angle DBC. And why are you allowed to say that? Why are you allowed to say that? You could substitute. What's another thing you could have done? You could like law of syllogism this. You could transitive property this as well. Either way, I'll write transitive property just because it's new, because it was something we hadn't done before. But you could have also just substituted DBC for this sum or whatever. But I'm gonna write transitive because it's kind of like a chain rule property here. Transitive property, and then that's what we were trying to show. So you're done. Let's brainstorm. Let's brainstorm here, folks. We know that we have this original equation. You have AB equals AM plus AM. What's a second very separate equation you could write based on that picture? What's a second equation you could write based on this picture?
AB equals AM plus MB.
Why should that be true? What says that this whole segment is equal to this part plus that part?
AM doubled.
No, let's focus here. Think about this. Why are you allowed to write this thing?
Because AB equals 2AB.
No, not yet. I can't get there yet. Spencer's got this. He's the postulate king.
Segment addition.
The segment addition postulate says that you could add the smaller parts and get the whole. So you could, totally separate from this original statement, you could use the segment addition postulate to get this thing. My segment addition. And if you know this, then how's the rest of this going to go? How about then we could substitute. And after you substitute, then what will we do to finally get down to just AM equals BM? We could substitute. If you substitute, then we get what? We get, since these two are the same, then substitution says that these two should be the same. So then if you had this is equal to this, how are you going to get what we want to show? What could you do? If you know that this is equal to that, what could you do so that you're only left with AM equals BM? Okay, let's be more formal than cross.
Subtract AM.
You can subtract one length from each side. Subtract one of the AMs from each side. We'll end with subtraction. It's kind of our rough outline. Now let's see how to actually write this up. And this I'll do as a map.
Oh, goody.
Okay. This will do as a map. So, as with a 2-column, we'll start with our given statement. So we have AB equals AM plus AM. And this is a given statement. Okay? In map form, this is a given statement. Okay? That's that part of our sketch. We also said we could come up with this by, and Spencer told us it was the segment addition postulate. Now, my thought to you is when we're drawing this, did we need to know this given statement in order to make the second one? No. These two things are very separate from each other. So in our map, we'll diagram them as they are separate from each other. Say AB is equal to AM plus BM. And that's the segment addition postulate. Okay? Those are separate ideas. They are not linked together yet. One did not come from the other. They are separate. But when we combine them together, what new equation can you make? when you combine them together using what? Substitution or transitive property, whichever one you want to use. Close transitive property as well. Alternately, you could have called it transitive property. If you take the first equation in our sketch and the second equation in our sketch and combine them together with substitution or the transitive property, whichever one you want to call it, then we can get this new equation. And if you have this equation, then we said what was our last step to show that AM and BM are the same? How about if we subtract the same thing from each side? Because they both have an AM in them. Let's subtract and get AM equals BM or MB. And you're done. We're going to jot down two quick ideas here. This is remembering some definitions that we'll use eventually. Congruence of segments. Two segments. This is recalling the definition of congruence. It's a subtle idea. Folks, it's a subtle idea, but an important one. In that two segments are congruent if and only if, the definition, their measures are equal. This is really invoking the difference between what congruent means and what equal means. Okay? They're very similar, but also distinctly different. Two segments can be congruent if their measures are equal. Two segments are equal if they're exactly the same. Two segments are equal if they're exactly the same. Like they're the same point in the same spot on the same plane. But if you say took that thing and cut and pasted it and drug the second one kind of somewhere else in the plane and maybe called the two endpoints different names, they're not equal anymore, but they're congruent. Their lengths are still the same, but they're not exactly in the same spot using the same points. Okay, so it's the subtle difference, but it's a distinct difference. Okay, similar with angles, two angles are congruent if and only if their measures are equal. By jotting down some thoughts, some pre-work, and think, well, why should this be true in the first place? Okay. From this sketch, let's write ourselves a proof. And would you rather do a map or a two-column?
Two-column.
Sure, we'll do two-column. We'll get a two-column guy here. So from our sketch, from our brainstorm, let's actually formally write this. First, we'll write the given statement. And I'm so lazy, I'm going to do this. Because I don't want to draw it again. I don't want to write that stuff again. That's given. That stuff's given. B is the midpoint of AC. C is the midpoint of BD. And that stuff is told to us is true. Okay? From our sketch, we really wanted to claim these two equations. Well, we can do that. Length AB is equal to length BC. Length BC is equal to length CD. And why is that true? Because they're the midpoints. If your answer is because that's what it is, that's a definition. That's what a midpoint is. A midpoint tells us those equations. That's the definition of a midpoint. That's why they're useful. And knowing these equations, why did we claim this? Well, we jotted that down. And from those two equations, you know that AB is equal to CD because of the transitive property?